Now, the next thing we're going to simulate is computer lab printing. And the reason they say you might do this is it's expensive to invest in buying a lot of stuff and try it out, and you find out you didn't buy enough to actually solve your problem, or you didn't set it up the right way to solve your problem. So it may be less expensive to simulate some kind of system prior to investing in building it. This is true of a lot of cases. Anytime someone builds an airplane or a car design, they will simulate it, and they'll simulate a lot of the different systems in these two things before they actually build it. So they can actually answer a lot of questions about its performance, even the cost of doing it, when will it break down, how it behaves in a crash. There's a lot of things they can simulate now. When they build a bridge, they will use a mathematical model and put it on a computer that simulates the loads on the bridge for all the parts of the bridge, so they can make sure the bridge will support a load or survive in an earthquake. Anytime you build a spacecraft or a rocket, it's going to go places you can't even fix it necessarily. So they always simulate a lot of aspects of spacecraft and rockets before they actually build it. Even when you're building a network, there's a whole group that's working on the next network design. So how will we change the internet, for example, to behave better? Or how are we going to change how wireless systems like cell phones work better with each other? So rather than actually building a network and spending all that money, there's actually software that will simulate a network, and you can change aspects of how it works and then simulate it and find out its characteristics. So you can save a lot of money by doing that. One of the most common simulations you might use is a simulator where you interact with a simulator. So you have a real, quote, real world simulation of some way, and you interact with it. And the most common experience you may have had for this is when you play games. When you play a lot of shooter games or action games on a computer, you're actually involved in a simulation. So the example in the book shows how to simulate a bunch of computers printing in a lab environment where we have several printers, and we want to ask the question, well, what's the maximum and average wait times for getting a printout prior to buying the printers? So we have a lab that has a certain number of students, and we know they print on a certain statistical way they print behavior. So we want to see what's the maximum wait time, for example. Now this type of simulation is actually going to simulate time. So the idea there is you have a main loop that simulates 1 second each time it goes through the loop. And that's how you simulate time. Now of course the computer can simulate much faster than in real time. So the loop may go through 1 billion iterations in a second. So you can simulate 1 billion seconds in 1 second. And that's one of the advantages also of simulation, is if it's a simple simulation, you can simulate before things happen. In fact, this is how the weatherman does things. There's some very, very expensive computers, and they have a model of the weather, and they input what is the current weather, and it simulates what it's going to happen. And they have it now where they can simulate up to 10 days in advance and report it on the weather. Of course, a lot of the nature of simulating very complex systems in the world is it's only an approximation. So they're actually approximating the weather, and that's why the more time they get out, the less accurate the prediction is. It's also why even for predicting rain, they give you chances of rain, because they can't simulate all the chaos that's actually exists in the real system. And they also can't actually simulate it in the amount of precision of the real world. Now also, when you study the code for simulating the lab, you're going to see some more uses of object-oriented programming. So they have a printer class that represents each printer in the simulation. So they define methods that will interact with the other classes. They've added a task class, which represents when a student wants to print something and adds it to the task of printing something. It'll represent that task. So the task might be printing a certain number of pages, or a print job that takes a certain amount of time. And then they just add 2 more functions to help run the simulation, one that has the main loop, and so we can look at that. So let's look at the code for this. Oh, there's a little diagram first. Well, there's this description, so how they're going to do it. So they're going to use a queue for the print task. So they're going to create a queue of the print task. Each task will be given a timestamp upon its arrival. So in the simulation, the timestamp will tell when it was first put in the queue. The queue is empty to start. Now for each second of the simulation, they say, does a new print task get created? If so, add it to the queue with the current second as the timestamp. If the printer is not busy, and if a task is waiting, so this is all in this loop for each second. So if a printer is not busy and there's a task waiting, they're going to have to print it. So they remove the task from the queue, assign it to a printer, subtract the timestamp from the current second to compute the waiting time for that task. Then they append the waiting time for that task to the list for later processing. Then based on the number of pages in the print task that's been simulated, they're going to figure out how much time it will be required to print. Okay, and then these are all things happening that second. So in the next second, still in the second, if the printer now does 1 second of printing, so they're going to ask the printer to actually do a second of printing, and it subtracts 1 second from the time required for the printing task it's working on. If the task has been completed by the printer is no longer busy, so the printer is going to change its state. So after the simulation is complete, we compute the average waiting time from the list of waiting times generated. Please subscribe to my YouTube channel. You'll see an icon in the lower right corner you can do that with.